Thank you. Yeah, that bumped up me. Yeah. Even before I just get into this topic, I'm just seeing a pattern between this plaza room and the presenter's name not available in the, the schedule papers that is printed up across. Actually, the presenter for this paper is mentioned as Anil. He's a co-author of this topic. I'm basically from India, and this is my first presentation that I'm doing in PNSQC. Okay, so sure. I'm not able to. Yeah. Maybe. Yeah. Okay. I'll just skip the about part of us and the agenda. The agenda of this topic is, when should the quality be considered? What are the architectural decisions that we addressed in our current project, and what are its quality aspects, and how the architectural decisions impacted quality for our current project. This is my typical agenda for today. Quality. Quality is something that should not be, queued up until the validation phase. Quality aspects is being, widely spread across the system, and hence its implementation also should be considered system-wide. During the software development cycle, quality should be considered throughout the software development cycle and not just be pointed during the validation phase. So the quality should start from requirements collection to design, and from design to implementation, from implementation to validation, and until the release of the product, the quality should be considered. I'm going to talk about the architectural decisions that we made during our design phase, which improved our quality, and how we were successful enough from our previous project to the current project. So here, what kind of architectural decision constitutes? So even before that, I'll just say, what is architecture? Architecture is the blueprint of the software, and who actually owns the architectural decisions in the design phase? Are there any architects in this room? Yeah. Okay. You held my breath now. So generally, the architect's role is to weigh upon different options and then finalize on the best approach to design the software. And this typically depends upon the main thing, business requirement. And then, it also depends upon the sustainability of the product in the market, and, the feasibility of this product to grow itself by adding new features to it. Apart from that, though my topic is more about architectural decision that impacted our quality in positive sense, architectural decisions do impact the other aspects, like the functionality of the software, the implementation. During the implementation, based on the decisions that we have made, it do impact the implementation, scalability of the product, and the extensibility of the product. Right? What are the quality aspects that were addressed during our architectural decisions, right? The basic factors for us for this quality aspects were, the user experience of the product, the behavior of the product, and also the security of the product, without much security loopholes with the product. And here is a list of quality aspects that we achieved: performance, generating code maintenance, portability, validation, and scalability. uh, throughout our software development phase, or the design phase, we had made lots of architectural decisions, but I'm just going to talk about the four key architectural decisions that we made that impacted our quality. And in the previous slide, those quality aspects which I mentioned, um, it's telling like not that every architectural decision that we took, right? Not all these quality aspects were achieved in each architectural decisions. There were trade-offs between each architectural decisions that we made. Say if there was, out of four, two of the architectural decisions achieved performance improvements, and two improved our code generation. So there was quite of trade-offs between the quality aspects and the architectural decisions. So let me go on to the first architectural option that we had to run through. Based on the business requirements, our architect had to choose to run our core business logic on a single thread, right? Either a single thread or multi-thread, and he did have options with multi-thread to either go with a fixed thread count or large thread pools. Now, I'll just give you, in each of the architectural options or the decisions that we made, I'll just give you a little background of why did it really matter for us, and all these things I'm going to compare with my previous project, and what were the drawbacks between the previous project decisions, and what went through well with the current decision that we made. So the background is our previous project was a multi-threaded application, and it was, though it was stable enough, and it was deployed on 80 million nodes over a decade, right? But the problem it was not really working well for us is our business logic could have been sequential, right? Generally, this multi-threading is more inclined to, when we selected in our previous project the multi-threaded programming, we were more inclined to, we should do multiple operations, simultaneously. It was more inclined to that part, but for us to succeed further, we need not have been to be multi-threaded. We could have achieved being sequentially. And then the field escalations, what we see when we analyzed all the high severity defects. When we analyzed those, we found out that most of the defects, right, ended up into the way we use the multi-threaded programming, right? So we were getting lots of field escalations, and then when we did cross-module integrations, the resource utilization was not well thought through. So what happened was, like, say now we had a patch 1, and there we had to fix a bug. During the fixing of bug, we had to develop a module, and later in, say, patch 2, we had a new feature, and we also developed a new module over there. When integrating the module 1 and module 2, our resource utilization was not well thought through. So again, though during the integration everything seemed good, and in the testing phase everything did good, but when the product actually went to the market, we were encountering again high severity defects in the race conditions. And that also again is due to the multi-threading approach that we had taken up. So our architecture decision number 1 was that to run our core business logic on single thread. And what really worked well for us by adopting this is our code became sequential. We were able to avoid locks, And then with multi-threading, right, there is always, the traditional synchronization issues. Those synchronization issue with the decision of going with single threaded, we were able to, chop off there. And then uh, we we avoided even being precautious when sharing the resources. So whenever with the multi-threading concept, the developers had to be extra cautious when they were trying to share the resources, to avoid the race conditions. And also whenever the data was there are multiple threads that running, and the common data, if it's getting manipulated, simultaneously, the end result of the data was not what we were looking for. That the data was getting manipulated. So those kind of issues we have avoided by running a core logic with single threaded. And then our debugging also became very easy, because it's just a single thread that is running alone at a time. And then code generation. Our product is a framework product, which has to integrate with multiple products and those products whichever integrate with our product do depend lots of operations on us. And we are also spread across platforms. We do support Windows and non-Windows platforms. So with multi-threading, what happened for us was that we had to write wrappers for each platforms, which used to abstract the multi-threaded the thread APIs. And then we had to use that wrapper into our code. This was becoming difficult for us when we had to support multiple platforms. And apart from that, when we went with a single threaded programming, we avoided the threading modules, and it became easier for us to develop a platform agnostic code. So this is why we had to go with single threaded, and it did work well for us. And the next architectural option that we had to decide upon, since the first architectural decision we went with single threaded, now we had to decide upon with single threaded what kind of IO calls work well. Will blocking IO calls work well, or non-blocking IO calls work well? With this, again a little background. Our previous project was multi-threaded with blocking IO calls. Though the programming was linear programming, and the code was easier for us to develop for a framework product like ours, but then the problem was the threads used to get blocked. Often the threads used to get blocked, and the threads which are blocked for continuously, we end up that the CPU cycles get wasted, and also while processing these threads, right, the time consumption is also huge for us. And if any resource high resource intense task was planned on these threads, then it became very undesirable for us. The next problem was even contact switching between the threads by the CPU also started taking too much of time, and this actually dipped our performance. And then we were seeing lots of deadlock issues. With the history of many field escalations that we were getting into, and this software industry, we have people coming in and going out, and when new engineers started fixing the defects, they used to spawn lots of threads, and then and it was not maintained, and we used to end up into deadlocks. And the faster we sent the product to the market, it used to just bounce back telling that you have deadlocks, we are unnecessarily the resource consumptions are happening. So these kind of issues we encountered. And even the integrators saw lots of performance issues with multi-threading programming, multi-threading non-blocking programming. So the decision that we went with was single-threaded with non-blocking I/O calls, and what worked well, this asynchronous non-blocking I/O calls, right? Uh, I know, even before that, this multi-threading, right? As I said earlier, why we were inclined to multi-threading is to do multiple operations simultaneously. But this asynchronous non-blocking I/O calls provide parallelism. So with that, even with the single thread, we were able to achieve parallel operations. So, and apart from that, it also provides something called notification, so that and user, and our product provides certain services. Certain services have been exposed to products. So when they try to use those services, it is and if they decide that just they need to initiate the operation, and then they don't want to wait for the operation to complete, and then they can decide on the next operation and work and concentrate on that operation. And whenever this operation is completed, a notification is sent, and whenever the user feels that he needs this information, he can pick it up and go. So that worked well for us, and so we ended up choosing this single thread with non-blocking I/O calls. With this, what we achieved was resource utilization was fairly done, and we didn't encounter deadlocks, and there was no unnecessary wait between the operations. Right. The next architectural option, reuse of components. I think since yesterday, whenever I attended the conference, I saw many people prevailing around security. They were talking about this pretty often, about reusing of components, third-party components. So we also had to decide upon to for the standard infrastructure component, should we really reinvent the wheel by developing the component, or just and third party to component is available, just integrate that and go ahead with our core solution development. So the architect had to choose to either develop the new component for standard infrastructure structural needs, or reuse the the components that is available in the market. So again, a little background, what didn't go well with us. In the previous project, whenever we tried to do the whenever we try to have this standard infrastructure, we developed our own component. And when I say infrastructural components, right, to just give an idea what it is, it's like to do some kind of network operations, like download the files from an HTTP server, or for open SSL communication, for crypto operations, and such kind of operations is what we have termed it as common infrastructural components. And in the previous project, we did develop our own network component, and with this, what we ended up was that we had to build lots of expertise between the engineers, and this was not a core solution that we wanted to provide to the customers. We were investing time on building the expertise in an standard infrastructure components. And then there was lots of duplicate code. As I said, our product is spread across platforms. And when we developed, initially we had developed this only for Windows operating system. And then as and when the need came to add the additional platforms, we had to write code separately for non-Windows, and that ended up as a duplicate code. And with this, if there was any issue in the infrastructure components, right, it used to be a single fix. But since the code was duplicate, we had to put the fix in multiple location, and this started, giving us like overhead of maintaining the code. and there were lots of stability issues in this area. And main thing, we didn't adhere to any standard performance or security constraints. So what was the decision made? For all the infrastructural needs, and if there is standard components available, we'll reuse them. That was the decision that we had made. And with this, what did we achieve? Our developmental cost reduced, and mainly we invested time was on identifying the component that best suits for that operation, and then the integration time is what we spent, instead of reinventing the wheel completely. And then it was an assured quality, because these components which is available in the market were developed by the subject matter experts, developed and validated by subject matter experts, and also this has been openly available in the market. So it's just not our company who's going to just test this product or utilize this product. There are many others who are already using it, and we did get the confidence from the other people using it. And it did increase our velocity. Again, it tied up to the developmental cost, where we could only concentrate on our core solution development. And it did adhere to the open standards. So this was the third. And a small case study we did on our component in our previous project. We had developed an HTTP server. With this, what happened is, again, I did give an example of a network operation stuff, but we also, for the HTTP server, where we had to download contents from an HTTP server and provide to other products for it to be up to date. For these operations, we had developed our own, we developed it in-house. With that, it ended up to be having two different code base. We had performance issues while serving large files, and also when a file was simultaneously served to multiple clients, we used to see lots of crashes in the field, which is again a bad remark for the product. In the current project, we use this Node.js, which is an any one of you use Node.js? Yeah. I mean, with this, we did get the cross-platform support. It's just a single code, and that can be utilized between used across the platforms. And then the best thing is, it is an asynchronous calls, which again align to our previous decisions that we had taken, the single thread with asynchronous calls. So it did align with that, and also there were lots of performance issues we got addressed. And the benefits with this thing, what benefits did we achieve was that our product is there. The new product is there for past 1.5 years in the market. And when we did an defect density report, when we collected the high severity defects that we encountered were not in these reused components. It was more to our core solution that we had provided, and not in this area. But when we had developed our own component, it was like the ratio was equal. 50% was on the developed component, because we didn't have expertise over there, and then 50% on our core logic. So that was one thing. And apart from that, it also speeded our releases. And in between the releases, there was not much changes in this reused component. So we did find lots of velocity over there. And this is the last architectural option that I'm going to talk about. Is either enhance the current design, or kill the current design and then redesign. So this is what the key architectural decision that we did with our current project, and why we had to do this. Though our product was there in the field for more than a decade. When I say decade, it's just not 10. I think it's like 15 plus years. It is there in the market, but it was not good enough to serve the next gen requirements for us. One is that we were not able to add, these days the embedded macros are emerging, not emerging, it's already emerged well. So we had to support these embedded devices, but with our previous project, we were not able to do that. That was one reason that we had to, think of, killing the design and redesigning it. And then we were not able to evolve further to satisfy the new customer needs. And there was a lot of incompatibility between the products and environment. When I say this, it's like, as I said, it's a framework product, and you have multiple other products that is relying on this framework. And in this ecosystem, everybody else was started, redesigning and getting into the next generation, but we were still with, the old thing, and we were not compatible. And again, we had lots of issues, and we started, fixing these compatibility issues, and then thinking about what next, what to do further. So these all motivated us to, redesign the product. And with redesigning, we achieved the better workflow of the product. With the previous product, we had understood what workflows the customers are generally using it. So we thought that it's important for us to first betterment the workflow. Say now, if an operation was to do, run an update on 10 particular systems, then we had to do around 6 to 7 steps to reach out to there. With this design, we were able to achieve within 3 steps. So we tried to give better workflow for the customers. And the adoption rate was huge. Over there, it was like 15 years we are in the market, and we just achieved around 80 million nodes. But with 1.5 years in the market, with the new design, we were able to achieve 22 million nodes. I mean, it is like, we were able to achieve that. And then we had improved compatibility. This is one more key thing why we were able to achieve the adoption rate got high, because we didn't say that, okay, I have redesigned myself, so when I go, whatever I am there, previously I'm not going to support all that. We didn't do that. Instead, what we did give importance to our back compat. So, and when our product got upgraded in the market, we ensured that we seamlessly migrate the old data to the new data, and we migrate the data seamlessly, and the products which is already using that data didn't had to even, I mean, there was negligible changes for them. They never felt that there was some huge change that has went through, and they had to do some fixes around it, right? We ensured that the back compat was given importance, and that is what I have mentioned in the other slide. It's like this is the old version which was talking to multiple products. When a new version came, they still felt the products which was already using our old version just still felt we are using old version, but then actually it was a new version which we translated them seamlessly. Okay, I have come to the conclusion part. So the conclusion is that we improved our quality with the architectural decisions that we made, and then velocity improved for the development. We achieved our vision, and then we were right time in the market. So what I would conclude apart from this is that if a design is bad, it's not that you cannot be in the market on the right time. You will still be there, but then you will start fixing the issues. More and more escalations will be there, and you will have to spend more time in fixing those issues. But if a good design is there, even if you're not on the right time in the market, if you're delayed with your release, still you will not be having the overhead of fixing the design issues or the escalations. More and more escalations may not get into the engineer's hands. So nicely designed product actually gets a high rating in the market. Any questions? I think. Yes.
So I appreciate you sharing your experience. Since architecture is the art of trade-offs, right? And the same development team or level of expertise doing the old architecture and doing the new one.
Mm-hmm.
When you're making trade-offs, if you traded out some bugs, quality issues, let's say, what did you trade in? What came back in instead, you know, in the trade part of it?
If I'm getting right, you're telling that the trade-offs, what we did with the quality aspects part you're asking about?
So
Or
if you improve some aspects of quality,
mm-hmm.
and it was based on an architectural change.
Mm-hmm.
Architectural changes are about trade-offs. What got traded in? What was the other part?
Okay. Traded in.
I guess we would find out later. Maybe we'll find out. Okay.
Yeah, okay.
No worries.
Yeah, but the thing is like yes, that's correct. Though we were there in the market, but there was there was lots of delay also. I mean, we had to push our dates now and then, but not with the the core version that we developed. But after that, whenever we tried to give a patch, right, there was little delay with that. There was a delay in our releases. Yes, sir.
It sounds like you may have been faced with a decision of, do we continue with, evolving or expanding the old system versus do we start with clean sheet, which is basically your option 4. So can you tell us anything about what led to that decision? What was the straw that broke the camel's back, or what was the threshold of pain that you encountered that forced you into that decision?
Yeah, the thing that I mentioned, right? We were not able to provide support for the embedded devices. We were having lots of customers coming into us, and they were requesting us to get us into the embedded market for the manageability purpose, and we were not able to provide the support with our previous version. So with the new architecture, where we were more of like service based than the complete framework, we were more of an service based. To provide the embedded device support, mainly we had to go for a redesign stuff. Yep. Yes, sir.
The trade-off between multi-threaded and single-threaded is that's a standard pattern. Do you know why the original architect chose to go multi-threaded and single-threaded was obviously better choice?
Then it was the I mean the architect who initially designed that was already left the company, so I don't know exactly why he did do that. But then when that decision was made, it was like fancy time when people said that, oh, it's a multi-threaded thing which can do multiple operations simultaneously. We can when I'm communicating to the server to get something, I can parallelly do other operations. But then it was a drawback for us, right? Until an proper handshake has not happened with the server, in between you get to do another operation, and that operation is going to manipulate this data. We were ending up into lots of race conditions, and then there were lots of field escalations. That's the reason.
Sounds like the answer is that multi-threading was cool.
Yeah, the thing is like the multi-threaded. I'm not telling that the multi-threading is the bad option, but for us, what really went well and was with single-threaded, we could achieve these things. So that is one reason that we shift our gear from multi-threaded to single-threading stuff. We could have achieved all our operations sequentially than doing it parallelly. The core logic.
So it sounds like you did an analysis of the problem of the application, and you decided that on balance, that single-threading solution was the best.
Yes. We did do lots of analysis on that part. because as I said, right, we did analysis on the field escalations. One time it was like, bombarding. Every 2 days you used to get in, high severity defects, and when we were like, okay, we have to now sit down and see what's really going wrong. And when we did that analysis of the high severity defect, and it's not that straightforward. It is multi-threading. The top layer is some other issue, but then when we do root cause analysis and go down, it used to end up into a multi-threaded issue. Time and again, that is, yeah. There was time and again, it used to be the multi-threaded issues.
Okay.
Yep. Yes, sir.
So did you consider any other alternatives, like something between like LMAX disruptor pattern?
I don't understand that. I'm so sorry. I'm basically from the QA background, so I know
It's like in between. It's,
Mhm.
has like the core of it is a single threaded, but it uses multi-thread on the outside.
Oh, yeah. So with asynchronous stuff, though our core logic is running on the single thread, we did achieve a parallel operations using, the threads over there. We did do that, yeah. Because just with single thread, we cannot achieve our operations. So, yes, sir.
I'm not a developer, I'm a tester. So my question is, when you're in the course of an architectural design, some applications are easier to test, easier to adapt to automation than others. Do you consider that in the architectural decisions that are made?
With the current project that we, worked during the design phase, even the automation was considered, and as and when the product got developed, our automation also, the framework also was, redesigned from scratch. And then by the time our product was in a good shape, we did have our automation also developed, so that it made easier for us to. We did have this discussion at the design phase itself, how to contribute on the automation.
Complexities of testing the software was discussed in the design phase?
The workflows were discussed. The testing complexity, not really. That was not decided at the design phase.
That's an interesting question.
Yeah.
Something that should be considered.
Okay. Yeah, I will take it further to my team. Yeah. So, any more questions? No? I'm done. Yeah. Thank you. The information, and thank you all for making to this talk.